Hello everyone, welcome to our Learnify YouTube channel. Today, we're going to be talking about osmoles and fluid replacement. Understanding these concepts is important for healthcare professionals, especially those who deal with fluid and electrolyte imbalances in patients. Let's start with the basics. A solution is divided into solute particles and solvent, usually water. Osmole relates to the number of osmotically active particles in a solution, and not to the molar concentration. For example, a solution containing 1 mole of glucose in a liter of water has a concentration of 1 osmole per liter. However, for some molecules, 1 mole doesn't equal 1 osmole. For instance, a sodium chloride molecule dissociates into 2 ions giving 2 particles Na++ Cl-. A solution containing 1 mole per liter NaCl will have an osmolar concentration of 2 osmoles per liter. A solution containing 1 mole of a molecule that dissociates into 3 ions such as Na2SO4 will contain 3 osmoles per liter. The 80% osmolarity of plasma and interstitial fluid, ECF, is due to Na+ and Cl-. 50% osmolarity of intracellular fluid, ICF, is due to potassium ions. Plasma osmolarity is slightly higher than other fluids due to plasma proteins. Now, let's talk about osmosis. It is the net diffusion of water across a selectively permeable membrane, from a region of high water concentration to one that has a lower water concentration. This process of water diffusion can be opposed by applying pressure in the opposite direction to that of osmosis, which is called osmotic pressure. It is an indirect measure of the water and solute concentration of a solution. Osmotic pressure is directly proportional to the concentration of osmotically active particles in the solution. 1 molecule of albumin has the same osmotic effect as 1 molecule of glucose. 1 molecule of NaCl has twice the osmotic effect of either albumin or glucose. Altering the tonicity of body fluid compartments can have various effects. For example, isotonic fluids such as 0.9% NaCl and 5% glucose have an osmolarity of 282 osmoles per liter, which means they have an equal water concentration in the intracellular fluid and extracellular fluid. Hypotonic fluids, which have an osmolarity less than 282 milliosmoles per liter, can cause cells to swell and burst. Hypertonic fluids, which have an osmolarity greater than 282 milliosmoles per liter, can cause cells to shrink. Now that we've covered the basics, let's talk about fluid replacement. So, when it comes to fluid replacement, there are 3 types of solutions: crystalloids, colloids, and blood. Crystalloids include normal saline and 5% dextrose. Normal saline distributes in the ECF only, with 75% going to the interstitial fluid and 25% going to plasma. On the other hand, 5% dextrose is isotonic, and the glucose is metabolized by cells, leaving water that is distributed in all fluid compartments. Approximately 2/3 of it goes to the intracellular fluid, while 1/3 goes to the extracellular fluid. For 1 liter of 5% dextrose, 666 milliliters goes to the ICF, and 333 milliliters goes to the ECF, with 250 milliliters going to the interstitial fluid, 75%, and 83 milliliters going to plasma. It is important to choose the appropriate fluid to use based on the patient's specific condition. In conclusion, understanding the concept of osmosis, osmolarity, and osmotic pressure is crucial for understanding fluid balance in the body. It is also important to know the effects of altering tonicity of body fluid compartments and the appropriate fluid to use for fluid replacement. And that's all for today's lesson on fluid and electrolyte balance in the body. I hope you found this information helpful and informative. If you did, please give this video a thumbs up and make sure to subscribe to our channel for more educational content like this. Also, don't forget to hit the notification bell to stay updated on our latest videos. If you have any questions or comments, please feel free to leave them down below. I'll do my best to answer them as soon as possible. Thanks for watching, and I'll see you in the next video.